How's it going, my little pumpkin spice lattes? We are going to talk about angles today. And I know what you're thinking, Barton. I've been learning angles since I was a wee little angle myself. Since I was in a cute little... That's so funny. Since I was in a cute angle. Get it? A cute angle. If I edited videos right now, I'd edit that guy on the Spanish interview channel where he says something and then just like wheeze laughs. That's what I would do. If any of you want to be YouTubers when you grow up, download this video, edit that in, repost it, get 1 million likes, profit. Okay. Until then, I'm going to teach you how to do some math. So we kind of have a lot to cover, and I have a couple stories we got to listen to, and you're going to love them. But we are starting our trigonometry unit. Trigonometry. Yeah, we're going to learn about this thing. This thing is the reason people quit liking math. This is what keeps kids from majoring in physics. Or what convinces kids that they should major in physics, and then they're like, wait, you mean physics is made of more than triangles? Excuse me? That's a true story. I almost majored in physics. I did for like a year and a half. And one kid in my very first ever physics class said, physics is easy. It's all triangles. The first time we saw a problem that couldn't be solved with a triangle, this kid was losing his mind, and he changed his major like a week later. It was hilarious. But what are you going to do? Haters going to hate. So let's learn about some angles today. We're going to learn how to measure them. We're not actually going to like measure them, right? I'm not going to give you the anglometer and be like, here's how you calibrate it. No, we're gonna learn about what different units we can measure them with. And you're going to be unhappy. But, I mean, when are you not? So get over it. All right. So let's talk about different things we can measure an angle with. Let's talk about what the heck is an angle, right? Like, it's one of these. Okay, but what? K? Like, excuse me? Like, well, what is that thing? So an angle is a measurement of rotation. It's how much spinning you do. It's how far in a circle you travel. And it's kind of like percentage. It's like what percent of the circle have you gone through, right? But percents are out of 100, right? There's 100% in a full thingy. So, you know, we don't measure it that way because that would be too nice. There's two much worse ways to measure it, and that's the one that everyone uses. Excuse my doggy door. My dog has no consideration for people making videos. So when we say an angle, we're measuring how much rotation does a thing do. How far does it turn? So one full rotation is a complete circle from wherever you started, right? Like if let's say I face that way, and then I do a full spin. What? Oh, wow, that didn't work. How come that stopped working? Full spin. You end up back where you're at. So angles, you kind of know what they are, but it's fun to make fun of how much we think we know sometimes. So let's talk about the one degrees, right? Every kid and their mom learns about degrees when they're wee little curmudgeons or whatever your parents call you. So a degree, one single degree is 1/360th of a full circle. If you think about it, degrees are so stupid. Why did someone take a circle and then say, cut that thing up into 360 slices? What? Excuse me? When have you ever ordered pizza with your pals and gone, let's cut this thing up into 360 pieces? Like, why? The real answer, do you want to know the real answer for this? The real answer is 12 is people's favorite number. I almost don't know if I want to tell you the full story, but I will. Maybe I'll put one of those like little caption things up here that's like skip ahead. But one day, one of my friends, and all my friends are, you know what kind of degenerates I hang out with. They asked me, "What's your favorite number?" And I told them Euler's number, obviously. 2.714 blah blah blah. That's legitimately my favorite number. And they go, "Nah, you're wrong. Your opinion's wrong. 12 is a better number." And it's hard to argue with this. 12 is a good number, and here's why. 12, let me think about it. Nah, not quite. 12 is divisible by so much stuff. Think about it. What can you divide 12 by? 1, obviously. Duh, everything. 2, yeah, also 2. 3, heck yeah, you can. Can you divide 12 by 4? We're 4 for 4. Can you divide 12 by 5? Nah, but 6 you can. Check that thing out. 12 you can cut up so much. Next lesson, on the next video you have to watch, I'm going to tell you why this is important. A guy got killed over this. Literally, they just took him out into the middle of the ocean and then threw him overboard and then drove home. And they're like, "See you, nerd." And they murked him. Incredible. But people used to really like 12 because you can cut it up really easy. And you know what 12 times 5 is? 60. And you know what 60 times 6 is? That number. Crazy. I don't know. There's a lot of 6s and a lot of stuff that... Like 360 is almost as divisible as 12. So people really liked it back in the day. Anyway, I digress. Make sure... Maybe that'll be a button. Probably not because, math. But... So degrees... Are you take a circle, you cut it into 360 equal little pie slices, and that's 1 degree. And then someone thought that was a good idea a long time ago. So that's where a degree comes from. Cool. All right, let's go look at the last one. This is the one that people, people, like lay people, regular people, knuckleheads, they use degrees. Real people who know what they're doing and don't screw around, they use this thing called a radian. And this is a new way to measure a rotation. So the way you get a radian, here's how you make a radian or find a radian. Okay, 1 radian is how far around the edge of a circle a radius of said circle would go. Check this out. Wop. That's so tight. Infinite cloner. Look, I can make a ton of these. But anyway, so here is the radius. The name of this line is the radius. It has a name. It's from the center to the edge. Because no matter what direction you point this thing at, watch it. I just changed the length, but you get the idea. No matter what direction you point this thing at, especially when you can stretch it, it will always touch the edge of the circle. Which is cool. Here, actually, watch this. I didn't mess with that one, right? Let's color over it. Watch this. Boop. Okay, let's take the blue one. Because the blue one, I think I can just spin. Heck yeah. Watch this. Spin, touches the edge. Spin some more, still touches the edge. Spin some more, still touches the edge. Incredible, right? It's almost like they made it like that. So if you take one of these things, wait, bring back my edge. Here we go. If you take one of these things and you put it right there on the edge, right there, and then you hammer this thing, what do hammers look like? Like that. You take a hammer and you go whack, whack, whack. Wait, whack. Come on. Whack. Oh, I give up. All right, it's unhammerable. But you pound this thing flat. Come on, let me pound it. All right, you pound this thing flat onto the circle like that. This angle right here, this is 1 radian. So if you take a radius, you pound it flat on the edge of the circle, The angle that's made by going one radius length around the edge, that thing is a radian. Tight, huh? Cool. So you can measure them this way. Fun fact. Guess how many radians there are in a full circle? Guess. Go tell your dog. Look at your dog. Look your dog straight in the eye. Longingly, like they want a hot dog or something. Tell your dog how many radians you think are in a circle. You're right. It's 2 pi, which is 6.282 something. Right? And you're thinking, why would I want to cut a circle into 2 and an irrational decimal number of things? I don't know. Why'd you want to cut it up into 360 things? But mathematicians like this. It's good for a lot of reasons, but that's one way you can do it. All right. So now that we vaguely know what a radian is, let's go talk about how we convert back and forth. Because it's like when you go to Europe and people are like, I weigh 72 kilograms. This number means nothing to you. Actually, some of you, right? Because I think some of you use kilograms. But for normal Americans, because Americans are dumb, they have to convert this thing into pounds first before it like means anything to them. They can't imagine what 72 kilograms is. They have to do the conversion to understand what this number means. Same thing with degrees and radians for you guys for a while. You'll get used to these someday, but for right now, you're going to have to think of them. It's like, okay, this many radians is this many degrees, and someday you'll get used to it, and then you'll quit thinking in degrees because they're whack. All right, so let's learn how to convert. You need to memorize this equation. So if there are 2 pi radians in a full circle, which is 360 degrees, you just divide both sides by 2. Pi equals 180 degrees. So pi radians, 3.14 data blah blah blah. Radiuses around the circle is equal to 180 degrees. Okay? So now you just divide that over. So pi radians is the same as 180 degrees. Okay? That's how we get this thing. This fraction is how we're going to convert back and forth. So all we have to do is multiply whatever we are trying to convert by this fraction, and it will convert it into the other one. But there's a trick to it. Sometimes you have to do the reciprocal so that it's 180 over pi, but it's really easy to figure out how to do that. So let's look at a couple examples. We want to turn 30 degrees into radians so that we can start learning the useful ones and get used to them. Okay? So we're going to multiply by a fraction. It's in degrees right now, and we want it to not be in degrees. So we need the degrees to cancel out. So if I have a degrees on the top here, I need the degrees on the bottom so that they cancel each other out. So if you want to go from degrees to radians, the 180 is on the bottom, right? So 30 divided by 180 is 1/6. And then we just don't mess around with the pi. Like the pi just stays where it's at. So pi. So 30 degrees in radians is 1 pi over 6, or just pi over 6 for most people. Cool. Let's do another one. I want to turn negative 270 degrees into radians. So we're going to multiply. I have degrees, so I need to cancel them and get rid of them. That means the degrees go on the bottom. Pi goes on top. All right. A negative times a positive is a negative. 270 divided by 180. 90 goes into this 3 times. 90 goes into this 2 times. So it's going to reduce to 3 over 2 pi. And then that's the answer in radians. All right. Now, oh no. They gave it to us in radians. What despicable, dastardly people. We've got to turn this thing into degrees so it means something to people, right? Normal people, not us. We're geniuses and we like this. but the rest of the people won't understand. So we got to turn it into something they'll be able to digest. We have a pie, and we don't like that. No, we like it. Normal people don't. So we got to get rid of the pie. So the pie goes on the bottom now. So that pi cancels pi, and then the 180 goes on top. So pi cancels pi, and then 180 over 2 is 90 degrees. Cool. So pi over 2 is a right angle. You might want to memorize that for the rest of your life. All right, one more. We have 11 pi over 6. So we have a pi. We got to get rid of it. So we got to cancel it with a pi on the bottom. Then we put 180 degrees on top. Pi cancels pi. Let's reduce this piece first. So we have 11. 180 divided by 6 is 30. So times 30 degrees. So this is 330 degrees. Almost a full circle, right? And if you think about it, 11 sixths, well, 6 sixths is 1. How many more sixths do I have? We've got 7, 8, 9, 10, 11. That's 5 sixths. So it's 1 and 5 sixths pi. That's almost 2 pi, and 2 pi is a full circle. So makes sense. All right, so that's converting. The long story short, you just multiply by either pi over 180 to turn into radians, or 180 over pi to turn into degrees. Cool. Let's talk about some important angles to know. At some point in the next couple of days, I'm going to ask you to memorize something like 30 different angles, and you're going to hate me for it, but it's tough love. It's like when your mom makes you eat your broccoli. It's just something you've got to do, kid. You're either going to do it, or you're never going to do math again for the rest of your life after high school, which is okay. Just realize that we all know you don't eat broccoli, and we're going to judge you for it. So, some important angles to just know off the top of your head right now. Of course, 0, this thing is a 90-degree angle. A straight line is 180 degrees. If I go 90 degrees past 180, 180 plus 90 is 270. And then a full circle is 360. Okay. I put these two on here just so that you can see what their radian equivalent are, because you're going to want to know these. Okay. So, you probably are familiar with these. These are fine, right? Okay. Let's go look at their radian equivalents. So 0 degrees is just 0 radians. And radians don't really have a unit. You don't write like pi over 2 radians. The fact that there's a pi here kind of just implies to everybody and their mom that it's in radians. Like, the fact that you're saying this is an angle, I already know it's in radians because there's a pi there. Okay. So 0 degrees is 0 radians. Let's go through the easy corners first. 90 degrees is equal to pi over 2. This you should memorize for the rest of your life. Half of a circle, 180 degrees, that's pi. Now, just like 270 is 180 plus 90, this angle in radians is pi plus half a pi. So this is 1.5 pies. This is an improper fraction, is 3 over 2. So 3 pi over 2, that's 270. And then obviously a full circle, that's 2 pies. Okay, cool. Now here's the important ones that you're going to want to like. These are the reason this slide exists. These are the two you want to know because it's going to come in handy in a couple of minutes. 30 degrees is equal to pi over 6. Cool. 45 degrees is equal to pi over 4. Okay, right? Half of 90, half of a half is a quarter. So half of 90, 45, pi over 2, pi over 4. Cool. You're going to have to get used to thinking in fractions. And I know. But Barton, you know my 3 greatest fears in life are being honest with myself, commitment, having dogs chew on my ankles until my feet come off, counting, and fractions. Oh well, suck it up, kid. You're in honors. Get used to it. Okay. One more that's not on the slide, but probably should be. What if I multiply this by 2? 60 degrees comes in handy for kind of the same reason 30 degrees comes in handy. So times 2, if I multiply by 2, I get 2 pi over 6, but you can reduce those. So pi over 3, that's 60 degrees. Okay, you're going to want to know that one too. So take a mental screenshot of this, save this thing, write it down, maybe even get a tattoo of it. Actually, hold off on the tattoo. We're going to get a bigger, better tattoo later. But memorize these for today. All right. So let's draw some angles in standard position. Okay. I'm going to ask you to draw 210. Now, the unaware person would just go, it's over there somewhere. This would get marked wrong on a test. If we were in real life and I gave you a not multiple choice question and you had to draw this thing, of course I'm not going to take a protractor, which I have. Check this out, protractor. I'm not going to take a protractor and then measure that thing because ain't nobody got time for that. But do you see how this thing and this thing look about equal? That shouldn't be the case. You need to draw your angles accurately. So we know that a straight line is 180 degrees. How much more than 180 is this? Well, let's subtract. Let's take 180 off. Let's see how much more it is. What's the difference between them? Subtraction. 30 degrees. So 30 degrees is a little less than half, so you need to make sure you're being accurate. Okay, so let's read this sentence before I forget. Start on the positive x-axis. Okay, so we need to have a line on the positive x-axis for our angle to start at. Rotate counterclockwise. That goes that way. So we're going to go counterclockwise 210 degrees. So we're going to go 180 and then 30 more. See how that's not in the middle? It's important. Okay? You want to be able to draw things accurately. Okay. It's also important that we have this line here to show us which way this thing spun, so we know it's spun that way. But it's probably not going to trip you out too much on the homework because there'll be multiple guesses. All right. So I believe that you guys could probably add 30s and 45s and 60s. You could figure out these ones. Let's go look at these terrifying, it's radicals, or radians. There we go. So 4 pi over 3. Let's turn that into a mixed number just to make it a little more digestible because I know you're terrified of fractions. All right, 3 goes into 4, so it's 1. How many extra thirds do I have? Well, I make a group of 3. 1, 2, 3, 4. I take 3 of them. How many are left over? 1 and 1/3. Okay, so we know 1 pi is 180 degrees. 180 degrees equals pi. There you go. Okay, so we're going to go pi, right? All right, start on the x-axis. Go 180 degrees. Now we need to go 1/3 of pi more. This is why we talked about it over here. What's 1/3 of pi equal to? 60 degrees. So we need to go another 60 degrees. That's what that extra 1/3 of pi is. So 45 is halfway. We need to go a little bit more. So let's go like that. There you go. We just drew our first radian angle. How tight is that? All right. It's important to note that if an angle is negative, it goes the other direction. You rotate clockwise. So this one's negative, so we're going to start here, and now we're going to go that way instead, because it's negative. So we're going to think to ourselves, all right, what's pi over 3? What angle is that? If only my math teacher had just told me on the last slide. 30 degree, oops, did I mess this up? Nah. 30, no, okay. Pi over 3 is 60 degrees. So I need to go 60 degrees that direction. So there's a half. Let's go a little bit more than that. How about that? Looks good to me. Again, I wouldn't use a protractor, but it's good to be precise. So there you go. There's how we draw angles in standard position. You're thinking, ooh, what a video. We're 25 minutes into this bad boy and you're still teaching, Barton? Don't worry. Uno mas. All right, so now we need to talk about complementary angles, and then I swear we're done learning about little angles for today. Isn't this hilarious? I'm so funny. Complementary, get it? Because he's giving you a compliment. Dang, you cute. So funny. Anyway, so what a complementary angle is in math. It's not an angle that says, dang, did you lose weight? You're looking good. Oh my God. Or, dang, did you gain weight? You looking thick, dog. You know, it's not that. Okay. A complementary angle, let's read the definition, is an angle formed by the terminal side. Don't worry, it doesn't have cancer. We'll talk about what this means in a sec. Of the angle and the nearest side of the x-axis. So it could be the positive side or the negative side. All right, so let's talk about terminal side first. The terminal side is the side that swings around. It's not the one on the x-axis. It's the other one. Okay, cool. Glad we covered that. So the terminal side is the like ending side. Terminal kind of means end, right? Terminal diseases mean it's the end. Sorry. Terminal of a bus station, it's like where the buses end at. They sleep there overnight, you know. Terminal means end. Okay, so it's the ending side. It's the other side, not where you start. And the angle formed by the terminal side and the nearest x-axis. So let's look at this first example. Here is my terminal side. Where is the nearest x-axis? You've got two options, A or B. Which one do you think it is? Tell your dog. Look your dog in the eyes. Confidently tell them. It's B. You're right. It is B. So the nearest x-axis is this one, right? This one's 135 degrees away. How far away is this? Okay, now we gotta do some math to figure out what is this angle between the terminal side and the nearest x-axis. So we know the whole thing is 180. This chunk right here, whoops, I grabbed the wrong thing. This chunk right here is 135. So we want to know what's the leftover. So we're going to do 180 minus 135. This is 45 degrees. So this little chunk right here, that's 45 degrees. So our complementary angle here is 45 degrees. All right, let's look at another one. I just felt like picking this. You know, I was like, what's their favorite number? So here's our terminal side. Where is it closer to, the positive or the negative side? The positive. Very good. All right, so let's figure out how far away this is. So you're going to say 420. What does that even mean? What that means is they went 360 all the way around, and then they went a little bit more. So this little bit more, that's what we care about. So let's figure out how much more than 160 this, or 360 this is. So we're going to take 420 minus 360. Let's see. Zero's good. Wait, we've got to borrow. All right, take one from there, put it there. 12 minus 6 is 6. The 3's cancel. It's 60 degrees. So we went 60 degrees past. That means this little section is 60 degrees. Okay, cool. You're going to notice here, I took the angle we know and subtracted it from 180 here. Here, the angle we know is the one that we're taking away from. It's kind of backwards. There's not a pattern to this where I can say, take the angle you know and subtract a number. You have to just think about it every time and kind of think about how close are you to something? Did you go past it? Are you not quite there yet? You got to use your brain. All right, last one. Here is our terminal side. Obviously, it's closest to the negative side, and we went a little too far. We want to, what's this tiny little angle here? So, this flat part here is 180, and we went too far. And we want to know how much too far, how much extra is there. So we're going to take 195, and we're going to figure out how far past it do we go. We're going to find the difference. 15. Okay. It's handy to know complementary angles should always be positive. So if you get the order of these wrong and you get like -60, just make it positive. It'll probably work out. All right. So now that I've bludgeoned you guys to death with vocabulary, terminal sides, complementary angles, radians. Oh my goodness, Barton, you're doing the most. It's my job. Okay. So now that we've learned about all these different types of angles and how to find them and how to label them and how to measure them, you're going to go do some homework. If you're scared, that's normal. Don't worry, it's a scary experience learning about angles. You didn't realize that your third grade teacher had introduced you to such a terrifying topic. Imagine if in third grade they're like, and next we're going to learn about taxes and your inevitable mortality. That would have been awful, right? Luckily, they save it for high school. So, if you need help, let me know. I'll be here. Otherwise, have fun on your homework. I'll see you guys later.